Hi everyone, this is Jason Lee. Today what we're going to learn about is a 2-axis joystick and analog inputs. I hope you enjoyed this lesson today because joystick has a lot of uses. Introduction. What is this really about? Well, we need to learn what joystick is first. If you hear the word joystick, the first thing that comes to mind is the game controllers. How do you think these kind of joysticks work? So you gotta have some experience with dealing with Arduino. You may realize how you move the joystick up, down, left, or right is going to be translated into a series of numbers, and these numbers will affect the sprite to move in the game. Now take a look at the joystick in our Arduino kit. Here is our little B103348 joystick. Not that different from the ones we just looked at, right? Except in fact this is way simpler. It is a self-centering spring-loaded joystick, meaning when you release the joystick, it'll center itself. If you look at its downward direction, you'll see a push button, which will be assigned as an output. Your kit should also contain a cup-type cap, which gives the feel of a thumbstick. Its main function is to communicate motion in 2D. 2D means something flat, two-dimensional, as if you draw something on your paper. What you draw is obviously what you can see, but it's intangible because it doesn't have a height. Same with joystick. This joystick can move horizontally and vertically, or a little bit of both, depending on how you move it. But it can't pop out or go down, so it's 2D, not 3D. We'll represent all the possible motions of this joystick as two separate values, vertical, or Y values, and horizontal, or X values. Plus, it has 5 pins, as you can see in the picture. We'll discuss what each pin does in later slides. So the basic goal of a joystick is to translate the stick's position on two axes, X and Y. Its horizontal position is going to be represented as X, and its vertical position is going to be represented as Y. Okay, so the joystick moves in X and Y directions, but how does it send out signals? The answer is potentiometers. It measures voltage by comparing differences in resistance of a potentiometer. A potentiometer is connected to both X and Y joystick shafts, which interprets the position as analog readings. Okay, here are axes. The potentiometers return different values based on the position of the rod. The graphic shows the X and Y directions and also gives an indication of how the outputs will be responding when the joystick is pushed in various directions. For example, the X value varies from 0 to 1023 as it moves from the left to the right. The Y value varies from 0 to 1023 as it goes down, but when you don't move the rod at all, both stay at 512. Do these numbers look familiar to you, like at all? Well, I previously mentioned briefly about the potentiometer. In order to read the joystick's position, we're technically using two potentiometers to measure the change in resistance. This input is read by an Arduino analog pin using ADC, or an analog to digital converter. As the Arduino board has a resolution of 10 bits, which means 2 to the 10. The values on each axis will vary from 0 to 1023. Pinout. Here's what each pin does. The first pin is GND, which means ground. The second pin is VCC, the 5-volt power supplier. The third pin is VRX, an input that reads the X value. The fourth pin is VRY, an input that reads the Y value. The fifth pin is SW, an output from the push button. We don't need the fifth pin for our project today. So our ultimate goal is to express the position of the joystick's rod as an ordered pair on the serial monitor. Components and circuit. What materials do we need, and how does our finished project look like? Here are the materials necessary for this project. First, Arduino Uno R3. Second, 4 single-pin female-male jumper wires. Third, joystick B103348. Here is the circuit design of our project. As you can see, GND on Arduino is connected to GND on the joystick, which was represented as black. Power pins are connected, as you can see the red line, and A0 or analog pin 0 is connected to VRX, as you can see the yellow line. A1 or analog pin 1 is connected to VRY, which was represented as green, and SW was left disconnected. And here's a picture of how I did. Now it's our coding time. Please open your Arduino IDE. So here's our IDE. Let's begin with defining the analog pin 0 and 1 to x-axis and y-axis. So let's use a define keyword. Define joy x analog 0. Define joy y analog 1. So what is a define keyword? Some may ask, why are we not using other ways to define these pins? For example, there's a way to use constant keyword, or you can actually declare it as an integer, like int joy x equals something. But I say define keyword is just most preferred. This define part is different in the sense that it is executed before you compile the entire code. So anything assigned with this define keyword doesn't allocate memory. There's no memory called joy y or joy x. Before compiling, all joy x and joy y are replaced by A0 and A1 respectively. It saves memory and the processor time. Is it that significant? No, not in this code, but it is a good practice to do so before you become an advanced developer. We're also going to declare the variables that are going to store the varying values of joy x and joy y. Just declaring, not actually assigning. Int x value, int y value. For the setup, all we need to do is to activate the serial monitor at a rate of 9600 baud per second. So serial.begin 9600. For the loop, let's assign the variables. X value equals analog read joy x. Y value equals analog read joy y. Now print the values to view on the serial monitor. Serial.print x value, serial.print \t, serial.print y value. This \t in the middle is called an escape sequence. This prints nothing but moves one tab to the right. Let's see whether this code actually works. So you guys can compile it, upload it, and open the serial monitor right here. And as you can see, there are a bunch of central values. As you move the joystick, you're going to realize how x values and y values are changing accordingly. So don't you feel like you can apply this into what you've learned so far? The last lesson was about servo. Maybe you can use if statements to make servo move only when joystick is pointing upward. We also learned about LED. Maybe you can make it blink whenever the push button is pressed. Or if you have more advanced boards like Leonardo, you can try replacing your computer mouse with a joystick. There's just countless ways to utilize it. Thanks for listening. If you have any question, please email me through chennylee77@gmail.com. Please hit the subscribe button if you haven't. It's not mandatory, but just do it. It takes that 1 second. Thank you. Bye-bye.